So here we go. Here we go. Question number one, real easy. All I'm asking you to do is pick out the ratios. Which trigonometric function is equivalent to s over t? A lot of questions yesterday saying, but like, how do you know which one's the opposite, which one's the adjacent? Here's the hypotenuse because it's opposite the right angle. And then depending upon what angle you're given right there, that determines the opposite and the adjacent. Like, three of these are r, so let me deal with that. So if you started with r, this side would be the opposite, and this would be the adjacent. And so let's fill it out. Cotangent. Cotangent is it would be the opposite of that, adjacent over opposite. So it'd be t over r. Nope, you're out. Let's do secant. Secant, no two cos go together, so it goes with cosine, which means it's got to be the hypotenuse over the adjacent. Booyah! Right there. You know what I'm saying? Right? Yeah, nice. Okay. Here we go. Oh, look at that. Look at that. Looks like the same thing. What's up? Oh, that's annoying. There we go. My bad. Oh, look at that. They all seem similar. Okay. All right. Anyways, here's number three. Same deal. Here's number two. Same deal. That side's the hypotenuse. Then check it out. Three of them are r's and one is a t. Let's do the r's first, and then that'll help narrow down whether the last one is true. Here's angle r. This side is the opposite. This side is the adjacent. Let's do this. Cotangent is adjacent over opposite. So that's t over r. Nope, not you. Let's do this one. Secant. No two cos go together, so it's got to be the hypotenuse over the adjacent. Nope, it's not you. Cosecant, that's the same thing as sine. That's the hypotenuse over the opposite. Oh, 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 right there, right there. You know what I'm saying? You know what I'm saying? All right, let's play again. Question number three. We are flying. Question numero trace. Okay, let's see. Oh, we got a little bit of a more varied scenario here. Here we got two t's. We got two r's. Let's see if the t's check out. So this is going to be the opposite side, and this is going to be the adjacent. Let's deal with that. Cotangent is adjacent over opposite. That's r over t. Ooh, ooh. Did you see that? I was close. I was close. Secant, no two cos go together, so secant's got to go with cosine, which means it's going to be the over the SO. Nope. Oh well. Oh well. So watch this. I'm going to erase that because you see how it's starting over? These guys are now r's. That side is the angle we're looking at. Here's the opposite side. Here's the adjacent. Cotangent. Adjacent over opposite. Jackpot. Woo, woo. You know what I'm saying? All right, let's do this. In the accompanying diagram, the legs of that right triangle are 5, 8, and 17. Nice. The sine of A, 15 over 17. Come on now. What a joke. What's the what's up? What's the cosecant of theta? Well, let's label up our triangle. That's the hypotenuse. If this is theta, this is the adjacent side, and then this is the opposite. So what's the cosecant? No two cos go together. So which one does cosecant match with? Sine. And cosecant is the reciprocal. So cosecant of theta, let's write this down for everybody watching on the internet, is the hypotenuse over the opposite side. 5/3. That's it. That's it. Which of the following statements about the triangle is incorrect? Ah, very sneaky I am. Very sneaky. Let's do this. Guys, if you know that this is 90 and that's 45, how much is this one? Yes. Very sneaky of me. Very sneaky of me. Tangent. So the tan of 45 is A over B. Well, tan of this angle up over here, let me put a star here. If you use this one, the tan is opposite over adjacent. Yeah, that works. It's not incorrect. Let's erase. Let's start again. The cosine of 45 is adjacent over hypotenuse. Yep, that one will work as well. The tan of 45 is opposite over adjacent. This one is out. Now let's just check out cosecant, because there are some errors when we use ExamGen sometimes. Cosecant. Cosecant is a reciprocal of what? No two cos go together. Good. Cosecant of 45 should be the hypotenuse. No two cos go together, so it's the hypotenuse over the opposite, because cosecant is the reciprocal of sine. Hypotenuse? No way, Jose. Hypotenuse is not A. Whoops. And since we were looking for the one that was wrong, that's the one we choose. Anybody in here try and do their homework last night? Of course you did, because you guys are good students, and there's no makeups. So you found out that this question is what? Guys, let me get a boo. Boo! Down with this question. We're going to skip over it. Bye, question. See you later. Skip. Skip. Boo. Boo on that question. Woo! Woo! Oh. Time to go. Find to the nearest tenth how much the side x is. So, ooh, I was going to write sine just out of nowhere. But let me label this bad boy up. Yeah, Jess, this is 10. The tangent of 15 degrees equals the opposite side over the adjacent. And then what do we do next?
Okay, then you put the 25 and...
Yeah. And then we cross multiply. What else?
And then equals 6.6. It equals 6.6 times 10. This is your 10, so it's equivalent to 6.7.
You are amazing, girl. You know this, right? And you know this. 25, 10, 15. Woo! 6.7. Now, this is the one I couldn't wait to get to be honest with you. You don't get it?
Because I don't get like the A, B, and the B.
Okay.
Like that's what the...
Here's what I want you to do. You ready? Don't listen to anything your friends say, because I've seen some people say some real messed up stuff lately. Okay. So A to B is 10, B to C is 12. Now, what is the first thing that what equation are you going to use? Law of sines. Thank you. And it makes an awful lot of sense, since we have angle A and side A, to try and go for angle C, because we got side C. So the sine of 125 is to its side of 12, as the sine of C is to its side of 10. You cross multiply, you know what I'm saying? You want to see a cheap shortcut with cross multiplication? Okay. Look, do you see how the sine C is over here? You see how you'd be like cross multiplying like this 10 going up over here? So what you could do is say this: 10 sine 125 over 12 equals sine C. Do you understand what I did? Does everybody see that? Instead of me doing like, I skipped basically 3 steps. All right. Okay. And then we inverse the sine. Thanks, Jared. No, it was excellent. I'm glad you said it. I wasn't saying that condescendingly. I was saying like, good job. Inverse the sine because we're looking for an angle. Inverse that sine up. What do you get? Okay, let's do this. 10 sine 125, whoops. 10 sine 125 divided by 12, second inverse of the answer, please. Thank you. 43 degrees. So C is approximately 43 degrees. Okay? But then there's a hidden version of that, right? How do you find it? Or you simply do 180 minus that answer. Okay? And you get 137. So C is approximately equal to 43 or 137. The question is do they both work? Well, if the C is 43, look what happens. Okay, this angle's 125. This angle's 43, right? Does it work? Good. Take the other one, 137. You can already see it. I mean, this angle's already locked in place at 125. Can you fit 137 in here? Hell no. So how many triangles can be made? Just one triangle. How easy is that? What's up? And in the multiple choice, if you see 3 triangles, cross that off. That's ridiculous. That's a ridiculous idea. I know. It's on the regions. That's the funny thing. Why, I don't understand.
So you can't make
Oh, that sounds nice.
triangles.
Guys, let's play again. It's the same thing. Oops. Oops. Hold on. One triangle is possible. Let's go with A. Kelly girl, how we doing? Easy?
Yeah.
Okay, better? Good. Let's do this up. Draw up the triangle. Need to get a picture going, right? Side A is 5 rad 2. That's annoying. Side B is 8. Angle A is 45. How many triangles can get made from this? So we're going to do the sine of 45, same as before, over 5 rad 2 equals the sine of B over 8. I'm going to take a shortcut, as you know, right? I'm going to cross multiply. At the end of the day, it's going to be 8 times the sine of 45 divided by 5 radical 2 equals sine of B. That's amazing. That's awesome, because the sine inverse of 8 sine 45 divided by 5 radical 2 is going to be equal to B. Let's punch this in. Let's punch this into the calculator. We got that divided by, and here's what I think you guys didn't do. You got to put that in parentheses. Because otherwise it's going to divide by 5, multiply the answer by rad 2, and we get 0.8. You know what I'm saying? Ah. Aha. 53. B is approximately equal to 53 degrees. And what's the other option for B? 180 minus 53, that's 120. 127 is approximately equal to B as well. The question is do both of them fit? If they both fit, how? Exactly, that's the point. If they both fit. Yep, we got enough left over. And now here's the tricky part. Let's see. 45 degrees. We can fit 127 in there. Yes. Yes. 2 triangles possible. Oh my gosh, that was easy. I wish I had one of those stapled buttons. That was easy. Oh, whoa. Lot of words there. Lot of words there. Don't get freaked out. Hot. Sam is designing a triangular piece for a metal sculpture. That's cool. He tells Martha that 2 of the sides of the piece are 40 inches and 15. Saw a few key words here. Saw 40 inches, saw the word triangle, off 15. I'm going to just write it down. And the angle opposite the 40-inch is 120. Nice. Martha decided to sketch the piece that Sam described. How many different triangles can she sketch that matches Sam's description? All right, let's do it up. Let's do it up the same way we did it before. Let's do the sine of angle A. The sine of A is to 15 as the sine of 120 is to 40. And so basically what you're going to get is that the sine of A equals 15 sine 120 over 40. Same thing as before, sine inverse of 15 sine 120 over 40 equals A. How much is angle A approximately equal to? Let's see, 15. Let's clear my calculator. It's 15 sine 120 divided by 40. Second sine of the answer, please. Thank you. We got like, let's round that to 19 degrees. Or, what's the other option? Big number, big number, big number, big number. And so, do they both fit? Of course not, because you already got one angle at 120, right? The 19 fits in there. Good job, buddy. Way to go. But if this is 120, there's no way you're going to fit 161. Nope. Nope, nope, nope. Rejected. Rejected. And therefore, everybody knows what this symbol means in math? Therefore, one triangle possible. Right? We're on question 11. Let's do this. Guys, this is the stuff that we learned yesterday, right? This is the stuff we learned yesterday, but there's an added little twist to it, and that's what I wanted to show you. What's up, Dorman? You know what I mean? People are going to be like, we never learned this. This is nonsense. Guys, two angles are congruent. You learned in geometry that the angles opposite those sides are congruent. And therefore, this last side is worth how much? 120. Nice. And the formula applies, right? The formula that's on your reference sheet, actually. Area equals 1/2. You need two sides and the angle wedged between. Yep, that's it. Plug that into your calculator, you're good to go. Let's see, that's going to be, I wonder if I could do that in my head. I can't? I think I could.
Try.
25 times the square root of 3, and the square root of 3 is like 1.7. So 1.7, 0.7 of 25 is like almost another whole one. It's like 17 more. And if I had to bet, it's C. What? Oh, what, you guys thought I couldn't do that in my head? I happen to think it's C. Let's see if I could do this. Let's see if I could do such a problem without a calculator. Come here, calculator. Come here, old buddy. Friend. Oh, look at that. Look at that. Look at that. 43.3. 43.3. Don't worry. You two next week will learn how to do stuff like this in your head. Let's do this. Let's do this, man. Let's do this. Up, parallelogram. Parallelogram. Guys. What? Nope, not a rhombus. It's because all the sides aren't the same. it's a parallelogram, which means all we need are the two sides and the angle wedged between. And you don't do the half because there's two triangles in this one. You know what I mean? 6 times 8 times the sine of 30 degrees. Let's see if I can do that for you. 6 times 8 is what? 48. And 48 is going to be 24. Is it this one? Oh, tone. Watch this. So in a parallelogram, opposite angles are congruent. True story? So check this out. There's two congruent triangles there. See that? So you could do this formula, 1/2, two sides and the angle wedged between, right? But that's for one triangle. But you got two of them. So you don't really need to take away that half business. We got two. All right. Let's do this. Let's do this, man. We're going to break this out. We are going to do 6 times 8 times the sine of 30 degrees. And it's 24. Now here is something that you might see on your test. As Dorman had suggested, what did we miss from Friday, right? You have to know, this isn't hard? Oh, Dorman, then you got nothing to worry about, homie. Okay, two adjacent sides of a parallelogram. Adjacent means right next to, 25 and 36. The parallelogram contains an angle of 112. Now, it doesn't tell you where the angle's located. Let's just assume it's up over here for people that are going to get all worried, right? Oh my God, it's not in the place that we need it to be. Yeah. There's two ways that you could think of it. You could say to yourself, I'm glad I studied in geometry because I know that opposite sides of a parallelogram are congruent. And booyah, you got two sides and the angle between. Or you could say to yourself, Ben? Yep. And 180 minus 112, I think, is 68, right? 68. I know what you're saying to yourself. You're saying to yourself, self, that's a different degree amount. Check this out. If you do 25, 36 sine 68, or you do 25, 36 sine 112, you get the same answer. And it's very much related to that question where they ask you how many triangles you could create. The whole reason you get the same answer is because the sine of 68 degrees is the same thing as the sine of 112. Right? So it's 800. What does it want? To the nearest what? So what is it? It's going to be 834. Let me just write it up on the board because that's what I do best. I mean, that was easy. Easy. Oh, let's see. What? You guys okay taking stuff down? Let's do this. Question number 15. We're going to draw a picture. Triangle ABC. That's A. Oh, B. Nice to see you. C. Welcome to the party. A is 15. C is going to be 20. And angle C is a hundo. So let's talk about some vocab. You know what the word acute is? Small. How small? Yep. Less than 90 degrees. And so we're going to try and figure this out. So here we go. We got angle C. We got side C. We got side A. Let's try and figure out angle A, and then hopefully we can figure out the other missing one and see if it's less than 90. So wait, do we have to do that? Oh, what we had to do was find acute angle A. Sine of A over 15 is equal to the sine of 100 over 20. Now I showed this in the other class. Actually, let me hold up a minute. Do you guys need a chance to take that down, or you're okay? Okay. All right, let's do this. So here's what I showed in the other class. You can simplify this cross-multiplying business, right? Check it out. I know that you cross-multiply, but at the end of the day, this stays over here and this moves up over there. So it could be just 20. Ooh, maybe not. Maybe not. Maybe it worked in the other problems. You know what? I don't like this shortcut business that I just did. Let's go back. Let's go back. I thought I could take a shortcut, but then it wasn't working out. Let's just cross-multiply it up. 20 sine of A equals 15 sine 100. Yeah, what I meant is like, yeah, that would go up over there. Watch. So divide both sides by 20. Divide both sides by 20. The sine of A equals 15 sine 100 over 20. Let's see. Who always asks me about this? How do you find an angle? The arc sine. The inverse. Okay. Sine inverse of 15 sine 100 over, 20 equals A, and A is approximately, how much? 48? Okay. Okay. So what does it want? We got to be careful. Is it to the nearest degree? So A is, in fact, 48, and that's acute. Oh, isn't it so acute? What an acute little angle. Anyways. Time to go. Let's do this. Up, LMN. L, M, N. L, M, N. Well, we're screwed. We got no angles. That's bogus. We don't even have a right triangle. We are in big trouble. Big, big, big trouble. Love cosines. Is that on your review sheet, reference sheet? Of course not. You're going to have to remember it. So what does it want? L? Oh, angle L. Oh, yes. Okay, so little l, little l equals, little l squared, equals m squared plus n squared minus 2mn cosine L. Yep. Yep. All right. Nope. Why? Do it. Lots of equations. Let's see. Plus 5 squared minus 285 cosine of an L. Oh boy. That's annoying. Well, this is 49. I can do some of this in my head. 64 plus 25 is what? 89. That was easy. Minus. Okay. And here we reach an important part. Can you ever subtract these two, 89 minus 80? No. Do not ever do that. Nice. I'm going to subtract that away. 49 minus 89 is how much? Negative 40 equals negative 80 cosine of L. Divide both sides by the cosine of L by negative 80. Whoa. Whoa there. That was messed up. Negative 40 over negative 80 is 1/2. 1/2 is equal to the cosine of L. And so check this out, right? I can actually do that in my head. It's 60. It's the cos inverse of 1/2 equals L. That's what circular trigonometry helps you do. It helps you do this stuff when your calculator goes dead, which often happens. Right? Take a look at all the calculators on my wall, for instance. Most of them have no batteries or are out of batteries. So what do you do when that takes place? You got to use circular trig. Oh my God, piece of cake, right? OMG. OMG? Yeah. Whoa, no. Go back. Okay. Yep, angle L is 60. The sides of a triangle are 5, 10, and 14. Find the largest angle to the nearest degree. I think we're doing the same thing, right? We're going to do the same thing. 5, 10, and 14. But some foolish person is going to run out of time. You know why? What's the foolish thing they're going to do? Yeah, they're going to do all 3 of the angles. And while you're not wrong, Skolnick, what's the shortcut? Yep. 14 is the largest side, so this guy, whatever it is up over here, let's call it, what do you want to call it? L or X? A? Okay, let's label this guy A. So this guy over here is going to be the largest angle. So 14 squared equals 5 squared plus 10 squared minus 2, 5, 10. Cosine of that, cosine of A. 14 squared is 196. 196, 25 and 100 is 125, right? 5 and 10, this is 100. Cosine of A. Subtract 125 from each side. What is it? 71? 71 equals negative 100 cos A. Divide by negative 100. Divide by negative 100. So cos inverse of 71 over negative 100, whoops, equals A. How much is A approximately? Is it to the nearest degree? Yep. Last one. Last one. You guys pumped? Let's do this. Last one. Let's do this. That's a horrible, horrible triangle. On a scale of 1 to 10, that was like the worst I've ever drawn. Okay. So this is A, this is B, and this is C. And angle A is 35 degrees. Angle B is 48 degrees. A is 16. What's the measure of side C? Oh, no. Go. I like it. I like your style. There's lots of ways we could have gone about doing this, but this is the most elegant. This is going to be equal to 180 minus 35 minus 48, which is how much, Dan? Okay. 35, 48, that's 97. Okay. So C is 97. Let's put it in here so you guys can see what's up. Then what else? How do you go from here? Yeah, the sine of 35 degrees is to 16 as the sine of 97 degrees is to side C. We cross multiply it up. Cross multiply it up. C sine 35 equals 16 sine 97. Divide both sides by the sine of 35. Sixteen sine 97. Good job. Calculator, please take us home. To the nearest tenth. To the nearest tenth. 27 point what? And that's it. That's your whole sheet. Good luck tomorrow.